Yeah, in this small lesson, we would like to find effective resistance between this point A and this point B. So whenever we need to find an effective resistance between any given points, what we can do is we can imagine a battery connected between the 2 points. So this is the positive plate of the battery. The negative plate of the battery is connected to the point B, so that we will be able to know how does the current flows. So from the positive plate of the battery here, current starts, current go this way, all the way, then comes to the point A. After coming to the point A, it will pass through these 2 ohms and it will reach this junction. At this junction, it will split. Some part of the current go this way, some other part this way, some other part this way. Let's talk about the current that is passing to this 4 ohms. It will reach this junction. After reaching this junction, it has a choice of traveling through this way, and this way. But see, if you see little carefully, the current that is going through this 10 ohms has no way that it can come back to this circuit or to the negative plate of the battery. That's like an open end of the circuit. Being that's the open end of the circuit, is the dead element of the circuit and no current flows through this because current cannot come back. So this is ruled out. Now the choice is between this line and this line. See, if the current is going through this 1.8 ohms, it has to further travel through this 2.2 ohms and come back to this junction. That's one choice the current has. The other choice is current traveling through this straight line. That straight line is an indication of a short circuit. Whenever no resistance is drawn in any circuit, that's like a short circuit. Short circuit means it offers zero resistance. So now the current has a choice of traveling through either zero resistance or through 1.8 and 2.2 ohms. Obviously current preferred to travel through less possible resistance and hence zero resistance. That means entire current travel this way, but no current travel through this 1.8 ohms and 2.2 ohms. That means what? These two resistors are also redundant in the circuit. They are not actually having any flow of the current. That's the beauty of the problem. That's the point that we need to understand. Now imagine, current after coming to this point has to go through either this way or this way. Yeah. Current that is traveling through this 1 ohm again reach this point and there is no way that it can come back. That's also like a open element of the circuit. That means no current flows through this 1.5 ohms also. Now look at this current. The current that was reaching this point, this junction, has a choice of traveling through this 1 ohm and through this 2 ohms. The same story. If the current travels through this 2 ohms, after coming to this point, it is no way that it can come back. That means that's also a dead element of the circuit. So this many resistors in the circuit, though they are physically present, they don't have any flow of current. That means they are not physically there, but they are not technically significant. They doesn't pass any current. So you can draw a equivalent circuit of all of that. Let me draw an equivalent circuit. Yeah. So let me draw an equivalent circuit. From the point A, this 2 ohms is there. This is what I am referring. Then after reaching this junction, this 3 ohms is there. Then here this 4 ohms is there. This is what I am referring now. This is the 3 ohms. Then at the bottom, that is a short circuit, zero resistance, current go very happily via that. Let me draw this 1 ohm now. Let me draw this 2 ohms now. I need not draw this 2 ohms. I need not draw this 1 ohm. I need not draw this 10 ohms. I need not draw. I have already drawn this 2 ohms. I need not draw this 1.8 and 2.2 because current is traveling through this zero resistance. And then after reaching this point, there is this 5 ohms and this is the point B. See, the equivalent circuit became much simpler than what is the actual circuit is. Now let us see how does the current flows. How does the current flows? Current go here this way. After reaching the junction, current will split this way. The current that is traveling through this 3 ohms will further travel through this 1 ohm and then reach the junction. It means the current passing through 3 ohms and 1 ohm is same. When the current is same, the resistors are in series, or when the resistors are in series, current is same in the other way. That means 3 ohms, that is this resistance, is in series with the 1 ohm, that is this one. When the resistors are in series, we know the effective resistance is R1 plus R2, that is 3 plus 1, that is equal to 4 ohms. That means instead of these two resistors, I can just draw one 4 ohms itself. And equivalent circuit, let me draw an equivalent circuit once again. What will be the equivalent circuit then? 2 ohms from where this point A is being started, point A, then 4 ohms. I am referring this resistance. This is a short circuit with 0 resistance. This is 2 ohms, that is this resistance. Now instead of this 3 and 1, I can draw only 4 resistors, 4 ohms. At the bottom there is 5 ohms, of course. This is the point B. So the current after coming from the point A to this junction is divided across these 3 resistors. Whenever current is divided, that resistors are in parallel. That means this 4 ohms, this 4 ohms, this 2 ohms are in parallel. First let us consider this 4 and 4 that are in parallel. 4 ohms is in parallel with 4 ohms. When the resistors are in parallel, effective resistance is R1 R2 by R1 plus R2. That is 4 and 4 by 4 plus 4. That is 16 by 8. That is 2 ohms. Means instead of these two resistance, I can write only 2 ohms. Then what will be my equivalent circuit? If you draw an equivalent circuit from A, there is 2 ohms. Instead of this 4 and this 4, I can draw only 1 ohm, one resistance, that is 2 ohms. There is another resistance, 2 ohms. And of course, from there is 5 ohms and this is the point B. Again, these 2 ohms and these 2 ohms are in parallel, the same formula. Resistance parallel is R1 R2 by R1 plus R2, that is 2 and 2 4 by 2 plus 2 4, that is 1 ohm. So what will be the equivalent circuit of this? 2 ohms, that is this one. Instead of this 2 ohms and this 2 ohms, I can draw only one resistance, that is 1 ohm. From here there is 5 ohms. This is point B and this is point A. See how the circuit is simplified. It becomes simpler and simpler when you go step by step. Now this 2 ohms current starts go this way, then it will go to this 1 ohms and then it will go to this 5 ohms and reach the point B. They are all passing the same current. That means that are in series. So what's the formula? Resistance between the points A, B, as they are all in series, is R1 plus R2 plus R3. What are they? R1 is 2 ohms, R2 is 1 ohm, R3 is 5 ohms. 2 plus 1 plus 5, 6 plus 5, that is, 3, 2 plus 1 is 3, 3 plus 5, 3 plus 5 is 8 ohms. That implies the effective resistance between the points A and B of the above problem is 8 ohms. That's it. Thank you for watching.